In question 8, remember the value of the x-intercept is when y is 0. So we could write this in slope-intercept form, graph it, and determine what the x-intercept is that way. Or what I think is much easier to do is put in 0 for y and figure out what x is. So in this case, we get 4x is equal to 40. So x is equal to, if we divide both sides by 4, we get x is equal to 10. So in question number 9, we're talking about Sam and Jeremy, and they have ages that are consecutive odd integers. So what does that mean? Well, let's list out a few examples. So if I have 5, 7, 9, 11, those are all odd integers. So as we can see, we're actually counting by 2's. Our first integer must be odd, though, in order for this to work. So if Jeremy, his age is represented with j, Sam's age must be j plus 2. So we know that their product is 783, and product means multiply. So j times j plus 2 has to equal 783. Now this doesn't look just like one of my answers yet, so what I'm going to do is distribute, and I end up with j squared plus 2j is equal to the 783, which is answer choice 3. Question 10 is modeling a population of birds, initially 20 birds, that is doubling every 10 years. Initially, that's my y-intercept. So if I look at my y-intercepts, I'm going to eliminate the graph where I don't have a y-intercept at 20. I'm also going to eliminate graph 2 because the bird population is doubling. This graph is decreasing. So now I have a 50-50 shot to get this right. And if something is doubling, that is definitely not a linear relationship. And just to verify, we start at 20 birds, and after 10 years, so right around here, it will double. So if I double 20, that becomes 40. It's right around there. It's a little hard to get it on the graph with the iPad stylus. And then after 20 years, that 40 will double to 80. For question 11, the lingo is very important. So we should know that domain and range each mean the x and the y values. So immediately I see a function, I'm going to graph it and make a table. So here is my table of values, and it's telling us to look at our function over the domain from 2 to 6. So the x values from 2 to 6, and we need to figure out the y values, and as you can see, the lowest y value is 0, where the highest y value is 8. Therefore, answer choice 1 is correct. Question 12 is important to recognize that a linear function means that we either have an adding factor or a subtracting factor. So we do not want a multiplier. And as you can see in answer choice 12, the bank account that grows at a rate of 5% per year, that is definitely going to eliminate number 1 because we'll be multiplying by 105% every year. The same thing in number 2, we have something that is doubling or times 2. That's yet again a multiplier. Those are both exponential functions. Number 3, the cost of a cell phone service that charges a base amount plus, well, there we see the adder. So number 3, I'm pretty sure is correct, but let's just go ahead and eliminate number 4, the concentration of medicine that decays by a factor of 1/3 every hour. That means we're multiplying by 1/3, and multiplying is not a linear function. 1, 2, and 4 are exponential. In 13, you first want to create an equation. So y is 3 more than half of x. So if we look at our graphs, I'm immediately going to eliminate answer choice 4 because it's a decreasing line and my slope is a positive 1/2. So my slope here is up 1 to the right 2, with a starting point at 3. So immediately answer choice 1 can be removed because it does not have a y-intercept of 3. And if I look at my two values for 2 and 3, the slopes of those lines, this is a slope of up 2 to the right 1, so it's backwards in answer choice 3, where answer choice number 2, we can see that that's the correct answer because we're going up 1 to the right 2, or down 1 to the left 2, down 1 to the left 2. With question 14, we need the average rate of change, aka the changes in the y's divided by the changes in the x values. So if I look at my x values, I can see that every single time we go down the table, we're adding 10. So the changes in my x values would be 10. I'm also noticing that my y values are decreasing every single time. So as I go down the table, every single time I'm losing 4/10. So I'm going down by 0.4. So right away I'm going to get rid of answer choices 1 and 2 because they're positive. And if I move this negative 0.4 to the numerator and I divide this through on my calculator, I'm going to see that that works out to be the decimal 4/100ths, and it will be negative. In question 15, the easiest strategy is to graph this polynomial and graph 1, 2, 3, and 4 to see which of these answer choices is the same graph as the original. But let's talk about factoring. We need to define two numbers that add to -12 but add to 36. These just so happen to be the same exact number of -6 and -6. And let's not forget, when we double distribute, the first times the first always multiplies to this first here if it's written in this format. So x squared times x squared is x to the 4th. Therefore, we can go ahead and select answer choice 1 with confidence. As soon as you see the word sequence, what are you supposed to do? Make a table. Here's my table with the information that they told us up above, that the third term is 10 and the fifth term is 26. So I have a few blanks here. The reason why I'm adding 0 in, even though there's technically not a 0 term, is my answer choices are all written as linear functions, which would make sense because arithmetic sequence means that we're going to have an adding or a subtracting factor. We can see here, because 10 is going to 26 in 2 steps, that means we are adding. So how am I going to get from 10 to 26 in 2 steps? Well, figure out how far it is from 10 to 26. That's 16, and just cut it in half. Therefore, we are adding 8 every time. Our missing value for 4 would be 18, because 10 plus 8 is 18, and 18 plus another 8 would be 26. So let's work backwards in the table by subtracting 8 every single time. Once we do that, we can see that our y-intercept, or the constant in the linear equation, is -14, making answer choice 2 correct. And we can also see the slope, because as we keep moving down the table, we are adding 8 every time we move 1 in our x values.